from previously. All right, hello. Now we really can get started. So the purpose of this session is to teach you a little bit about version control in a particular mode, which is the collaboration mode. So I'm assuming that if you're here, that you've used Git for version control in some kind of capacity. The way I think about it, Git, there are a few modes that you can use Git as a version control system. One way that I think of it is like a backup system. You work on something, and as you're working on it, you track it using, say, Git commits. And in fact, you can use very few commands. We'll show all the commands. We'll kind of review all the commands to do this as a version control system that lets you back up your work and checkpoint it as you're going along. And that's kind of one level. And then the next level is when you start sort of putting it somewhere else, maybe on GitHub. Or maybe let's all kind of show of hands. Who here has code that they put up on GitHub? Okay, a lot of, okay. But things get really, really interesting, perhaps, or kind of more elaborated when we start collaborating with others on GitHub. And things can get quite complicated also when you collaborate with others on GitHub, and or using some remote system. And we'll look at this today. The goal of this session is sort of to prepare you maybe for next week with sort of an established workflow. If you go online and search for like workflows that you can use using Git and GitHub, there are multiple options for how to use Git and GitHub together to collaborate. And I will recommend a very particular kind of workflow that I use in my work and that I think is a good one for collaborating. It's kind of the more, in some sense, it's a very general collaborative workflow. But we'll go through more specific use cases before we go to this more complicated one. I guess let's just to get ourselves a little bit warmed up. Why use version control at all? Maybe you can give me some ideas. I've talked about a few things here, but maybe you can give me reasons that we use version control in the first place. Yeah.
To make sure that two different people who are collaborating are working on two different versions of the same document.
Okay, yeah, so to make sure that collaborators are synced up on the same kind of, or on the same page, yeah. Other things, other reasons, yeah.
If you need to change that and create something, it's often good to compare it to how it was before to be able to make sure that you can implement the change that you want without causing other issues.
Yeah, so this is just to repeat that if you break something, you want to be able to go back to a state of your code that is not broken. Yeah. And hopefully we'll get to talk a little bit about how you make that really verifiable. Yeah.
You want to record all the changes you made with your difference so that every time you know what you have.
Yeah, it's sort of as a lab notebook of sorts, right? Like when did you make which change? So keep kind of track and you get the provenance of the code that you're working on. Yeah, those are all good reasons. I guess I also mentioned as a backup, I have most of the stuff that I work on is in GitHub. So in some sense, I'm not too worried about this particular machine or any particular machine because I make sure that I commit things to put them on GitHub. And that way I have a backup up there. Yeah, so all those are reasons. I think the one that we'll emphasize here is really more maybe this collaborative aspect. You can collaborate. One of the charming things about GitHub is that in the workflow that I will show you, you can collaborate with people that you know and trust, but you can actually start collaborating with people that you don't even know and don't need to trust because you can go through a process of reviewing their code and verifying it before you accept changes that they propose. So that will be kind of our goal here. And then hopefully, depending on the time, we might even go into like how you can automate those kinds of things, like checking other people's code, how you can automate that with GitHub. So you don't even necessarily need to read their code because it's automated. The checking of their code is automated as part of how GitHub works. Okay. So who here was actually in the previous session that I taught about Python software? So a few of you, but not all of you. And the way that I'm going to do this session is I'm going to use the code that I wrote in the previous session as a target for our version controlling. So for those who weren't here, and also for those who were here, in the previous session when I talked about Python software libraries, we developed a little library that does geometric calculations, and we organized it to have all the structure that Python library should have. So some of the things that you'll see, if you weren't in that session, you'll see all kinds of files that are in a folder, and that folder is the Python library. The details of some of these files are not too important, but the important thing is going to be that we're going to track changes that we're making in that place, in that code. So let me start working here. So I'm in the hub and I'm using a terminal window. One of the things that we all need to do before we start working in using Git in the hub is we need to configure Git. So I'm going to send you to the docs, to the Git setup page. And I'm going to ask you to follow these steps on your end. So these configuration steps are necessary because Git requires that you have, when you make a commit, that your name is known. Don't use Noah's name, use your name. And that your email is known. And we're going to do a little additional tweaks, like make the default branch in the repo be called main. And we're going to make sure that when we pull, we only fast forward. And we are going to also configure. So that's these configuration steps up here. And then the second step here is that we are also going to generate an SSH key and put that SSH key in your GitHub account. And that's so that you can interact with GitHub. GitHub doesn't allow us to authenticate with passwords. Instead, it requires some other method of authentication. And that second part here is entirely about creating the SSH key that we will use in order to authenticate with GitHub. So we'll need to do those things first before we go and start using that. I've already done that in my part of the hub. So please go ahead and start doing those things. Do folks know where to find this? And okay, have folks already done this? Who's already done this? Oh, several. Okay. Let's let the others take a few minutes to do that. And then I'll go and do something. Yeah.
How do I check if I've done install? Because I don't know. It isn't, I don't know if that's saying username is string.
How do you know if you've done?
I've done it in the.
Oh, how do you know if it works?
Yeah.
Oh, we'll know soon. We'll start running things and then. We have a Slack channel. It's Rokem-GitHub. Okay. Okay, let me know if you get stuck with any of these steps. Oh, interesting. Mert,
Yeah.
great suggestion. I guess I'll try this one. Why not? Cool. It's good to know. Right, so at the end, when you've set up the key, you should be able to run this and see something like this. You've successfully, this should be your username. You've successfully authenticated, but GitHub was not provide shell access.
For some reason, when I set up the key, it didn't show up in SSH. So I put something wrong.
Okay,
But I know.
so you got something. Here you
Yeah,
got, yeah. And this, by the way, just kind of for more information, this is something you need to do on every computer on which you're setting up Git. You need to do these configuration steps first thing. Okay, while you're doing that, I'll start slowly here with a few Git steps. So I'm going to go to, I am in my home directory, home Jovian, and I have from my previous work, I have a folder called source. And so far there's only one folder inside of this folder called geometry, but maybe in the course of my work, I'll have other repositories here. This is not a repository yet, but it will be very soon. And I might have source code from other things I could do. I don't know, git clone. There you go. So just as an example. So now I have DiPy as well as geometry. I have the source code for DiPy in there as well. But for our purpose, we're going to go into geometry. And in the previous work that we did, we created some files in here. And so very soon in my life, very soon after I create a directory and start working in it, the first thing that I do is git init. And that initializes this directory as a Git repository. To remind you, a Git repository includes a folder and all of its subfolders that are tracked by Git. So now if I type git status, I might see that there are a bunch of untracked files. And that's because I haven't added anything to the repository. But the fact that I can run git status is because this folder is already a repository. So let me add some things in here. The main code that I've been working with, kind of the bulk of the code that I've been working with, was inside of src geometry and was called circle.py. And so I'm going to add that. So git add is git init was the first command. Git add is a command that we use for two purposes. Git add adds a file that is not yet being tracked. So now we have git status that's changed. We have a new file in the changes to be committed. Does somebody know what that part up there is called, where that green thing is? I don't remember the terminology for that. That's the staging area. So where it says changes to be committed, that's what we call the staging area. That's where we stage things before we make commits. So we have that file, and we'll add another one as well. Add src geometry init py. This is a file that we call the dunder init file. For those of you who were not there for the previous, dunder is the name that we give to double under or something, double under, and is something that Python uses in all kinds of ways. That's the dunder init file. And now when I type git status, they're both in here. So git add is used in order to add files to the staging area. Files that maybe have not been tracked until now. And I can do git commit -m adds files to the repository. Or maybe I'll even give this something a little more distinct. Initial commit code files, initial code file or code files. It's pretty good. Guess not too bad. Okay, so I've added them. So git add is used in order to add files that are not yet being tracked, but it can also be used in order to for example, I added a little change in the code. This is as a reminder for those of you who were in the previous session and as an introduction for the others. This is the code that we are tracking right now. It's a Python file that contains two functions, one that calculates the area of a circle based on its radius, and the other that calculates the circumference based on its radius. And I noticed that this had said calculate area of a circle, and I like calculate the area of a circle better. So now if I type git status, you'll see that this is not in the staging area, but there are changes. So what git does when you add files into a commit, into the repository, it tracks the changes that happen in that file. In this case, it's tracking changes that have happened in this circle file. I can even see in detail what changes happened by using git diff, which shows me the difference in red, the things that were removed, in green, the things that have been added. In this case, a single line diff, the addition of the word the. And I can add this diff into the next commit or into the staging area by doing git add src geometry circle.py. And now if I do git status, you will see that there are changes to be committed. I've taken that file that where changes have been detected and I've added it into the staging area. So this is the kind of the dual role of git add, is to add files to be tracked in the future, but also to add changes into the staging area. And now I can do git commit -m. So git commit is the thing that kind of makes the checkpoint. If I use it with the -m flag, it allows me to write the commit message right on the command line. In this case, small change in doc string. That string next to the function definition is something we call doc string. So I made a small change in the doc string, and now git status. It says nothing added to commit, but untracked files present, and it even gives me the step git add to track. Okay, let me pause here and see what questions do people have so far. This is all I think should be a kind of a review of things you might have seen before, just in case you've seen something here that seems strange. Okay, good. Let's do another kind of, we look at this. So you'll see that I use git status quite often. I like to use git status a lot because it helps me. And when I look at this, I'm like, okay, this doesn't look very hygienic. Let's do some repository hygiene. One hygiene thing that we can do here is to create a git ignore file. Git ignore is a file that contains patterns that we want Git to ignore entirely. For example, these .ipy and b checkpoints that will show up everywhere in your repositories when you're using Jupyter, because Jupyter tends to make checkpoints of its own files. Those are, we don't want to track those. So nano git ignore. I add that pattern in here. Shim, I should just say, I open here in a text editor this file. Nano is a very small and relatively easy to use text editor. So when I type nano.gitignore, it opens that file inside of my terminal in the text editor. So I'm going to use nano sometimes here to edit. It's easier than opening, especially if that file has a dot in the beginning. It's hidden from the, you can't see it here in this, so it's easier to edit in nano rather than. And nano is nice because in contrast to other text editors, it has instructions at the bottom how to use it. So if I add, what else can I add? I'll add the build directory, which I also want to ignore. So write that, and I type this. I want to write this out. Write out is like save, Control O. It says which file, .git ignore, enter, and Control X, and that brings me back out here. So now if I type git status, the status has changed. There's a new file .git ignore, but you'll see that the build directory that we want to ignore, because it contains artifacts of like building the software. Ignore that one, and also you no longer see the .ipy and b checkpoint directories here. Yes, you had a question.
There, right? We know all the checkpoint directory and all the subdirectory.
Yeah, what we did, if you'll notice here, there was an ipy and b checkpoint directory down here, as well as up here. And when I added .ipy and b checkpoints, it ignores all the things that look like that. So you don't see it anymore. We do want to also ignore this one. This one's also an artifact of the build. So I'm going to do that as well. No, git ignore. Add that one here as well. Will this just work? No. I wish. Sorry, I need to try that again. How about if I copy it? Yes. Okay, good. Git status. Okay, so now git ignore is still, you can see that this list is growing smaller and smaller because I'm ignoring all kinds of things. I'm telling Git to basically not look at that. And the untracked files list includes only the files that it could be tracking. If I told it git ignore this thing, it's not going to include it in the untracked files. I do need to add the git ignore itself. So git add .git ignore. And by the way, I just hit the tab. If you saw that writing out very quickly, it's not because I type very, very fast. It's because I use the tab all the time in order to complete because I'm lazy. Git add .git ignore, git status, git commit, and you can see there's the new file, the git ignore, -m, adds git ignore. Okay. Git log. So git log shows me the list of all the commits I've made so far. I'm just kind of looking at it to see that I know what's going on. There are only 3 commits so far. The initial commit with the code files, some small change that I made, and now the addition of the git ignore. All's well in the world. Git status. Let's add the other files. Git add license. Git add read. Whoops. Add readme. Git add pipe project. Git add tests. Test circle. Git status. Okay. Ooh, look at that. I found some untracked files. Git doesn't, it can't really see stuff inside of, I guess, inside of folders that it's not tracking, but let's put this one in git ignore as well. I'm just trying to get here. I'm trying to get to a state where everything is nice and clean. You'll see what that looks like in just a second. Nano.git ignore and dunder PyCache directories are directories into which Python puts bitcode that it compiles. It kind of like temporarily compiles things and dumps it in there. We don't want to track those either. So git ignore is very useful. Modify git ignore, git commit, git add .git ignore, git commit -m, add PyCache folder to git ignore. Status, okay. Whew, I'm there. I'm finally here. So this is what I want to see, you know, at the end of the day when I'm done working or at the end of a cycle of commits. On branch main, nothing to commit, working tree clean. Cool. So this is kind of in some sense, a starting point for the next round of work. Let's say that I did some amount of work. I'm pretty happy with where I am, and I want to do a next round of work that will be focused on perhaps fixing something or developing a new feature. The first thing that I do when I'm thinking about developing a new feature is to create a new branch of my work. So git branch fix tests. I'll show you soon why I need to fix the tests. But we'll create the branch. And so now out of curiosity, who here kind of uses branches on a regular basis in their life? Okay, some of you, but not all of you. So I'll talk a little bit about branches because they're very useful. One of the things that makes Git very, very powerful is the ability to create what are called branches. And we'll look at this in some detail here. Branches are, you can think of them as copies of your file system that you can make separate sets of commits on. And that means that you can make changes over here and always come back to the main branch. So the main branch is the branch that we think of as the canonical, this is all working, everything's fine here branch. This is the thing that we created in this first set of commits. And in fact, after we do this first set of commits, I actually recommend not to work on that branch anymore at all, because that's going to be a branch that you will only bring into it things that you think are ready for kind of use or broader use. And branches, which are these other versions of the file system, are the places where I recommend to do little experiments or create new features, or in this case, fix things that are broken. So why are things broken here? Well, in our previous work on this, we got to the point where we were writing some tests, but then the tests were not quite working. And we know, whoops. And we know that because if we run our test harness called PyTest, it's going to do all kinds of things where I have some invalid syntax in there. Things are just not working. This, I'll kind of reiterate something that I mentioned before, but also for people who are not there. One of the ways to think about software development is through the lens of testing. Russ mentioned that also in his talk. The idea is that we write little code snippets that test the code that we're working on. In our case here, we have a file called test circle, and that file has a function called test area, which uses the code that we've written in order to calculate area, and it contains some code that makes no sense. In particular, this here is just a syntax error. So I'm going to fix it up by deleting these lines of code. Saving that. Oops, saving that. So now it has some, I need to install my code. Installing the package that I'm working on, so it's in my environment. I need to do that because I restarted my server since last time I've been here, and every time I restart the server, it cleans out things that I've installed since. So I had to install PyTest, I had to install my own code, but here we are now.
It worked before, no? Like when you did PyTest before.
No, it did a syntax check before it tried to import. So before it got as far as saying, hey, you got invalid syntax here, and never even tried to import anything. After that, I fixed the syntax, it checked the syntax, it said syntax is fine, but now I can't import this thing. And now it's saying I can import it, but you have a wrong assertion here. So again, we go and fix our code. So now The test, the logic behind the test is I'm using a test case where I know the answer. If the radius of a circle is 1, then when I calculate its area, that should be equal to pi. And here I'm using a Python assert statement. That means I'm checking this logical statement. If it's true, nothing will happen. If it's wrong, it raises an error. And that's what we saw before. We saw an error here. But now after I fixed it, and saved it, hopefully. Now the test passed. So I fixed the tests, so that's great. And now, so I'm happy here. I've kind of changed the code in a way that improves it. I can write a little git status and say like, oh, this is the file that I changed. That I'll work like this a lot myself whenever I'm developing. I'm like working on something, and then as a sanity check, I'll do git status to see, yes, the file that I changed has changed. Nothing else here has changed. I might even do a git diff here to see what are the changes that happened. So the changes that happened just during the little cycle that we did here are some removals of code. The area equals one thing, and these other code with the syntax error, those were all removed. And those are all good changes. Now the tests are passing. And I can do a git status. I think I still need to add this. Yes, git add tests, test circle, git commit -m fixes tests. Okay, so now I'm happy. I've changed this. Notice in previous iterations of git status, it wrote on branch main, and now I'm on branch fix tests, and that because I did git branch fix tests. I did write these, but I maybe didn't pause on these enough. Git branch fix tests and git checkout fix tests. And I should pause on these for a second just to talk about them, which is to say, this first one created the fix tests branch, and this one switched our working branch to be fix tests. Checkout, we'll see, is also one of those commands that does many things. The way I think about checkout is like checking out something from the library. So in this case, we're checking out this branch called fixed tests from the library that is the repository. We can very quickly also check out the main branch, and that switched us to branch main. When we do that, oops, I should do that. You'll see that the state of the code on the main branch still contains the stuff that I removed on the fixed tests branch. So this is what I mean by saying that these are different versions of the same file system. Again, I'll close this. I'll do git checkout fix tests. And I'll open this up again. Here it's fixed. And closing this first. Here, still broken. So I have on the file system, I can switch very quickly between different versions of the same file. It's not only that, if I look at the log here, the most recent commit is adding PyCache folder to git ignore. If I git checkout fix tests, and I look at the log, the last commit, that commit that was the last commit on main is there, but there's an additional commit on this. So the histories of these two branches are actually different. This new branch includes a commit that is not yet on the main branch. And then the next thing that I would like then to do is, if I'm happy with fixed tests, is git check out the main branch and git merge fix tests. And that'll put this little message out here, which is to update this branch from one commit to another commit. These little strings here are the identifiers of two different commits, the commit that we were on first and now the commit that we are now. It says that this is a fast forward change, meaning it didn't require doing anything too complicated. And it even tells us what happened there. The test circle, there was a removal of 6 lines. One file changed, 6 deletions. If there were additions, it would also have little green pluses in there, but there weren't any. And now if I do git status, I am on branch main, nothing to commit, working tree clean, git log now includes this new commit. So in effect, what I've done is I've created a new branch. I made some changes on that branch, tested those changes. I'm happy with them, and I'll merge them back into main. And after I've done that, I can git branch, -d fix tests, which deletes this other branch. So now I've gone kind of a full cycle. This is a full cycle of development. You create a branch, you make some developments there, and then you merge those into, once you've merged them into main, you can remove that branch and on to the next thing. Now, it doesn't have to be that you do this kind of discrete thing. What you will often find yourself doing is creating many, many branches to do many different things. And this allows you also to explore different things in parallel. Having a main branch that always works, right? You can imagine like you're giving a lab meeting, I don't know, next Thursday, and you have your code working exactly the way you want to show it in lab meeting, but you don't want to have to wait to make any changes until next week. You keep your main branch as it is. You make another branch for whatever experiments you're doing from now until next Thursday. And then right before a lab meeting, you switch back to main and you can show the code as it was working. So that's part of the idea here, is it lets you do many, many experiments, some of them, and you end up merging into main. And maybe some of them you say, okay, this is not something I want to do, and you end up not merging. Okay, what questions do people have? Yes.
And the new branch, is it always a copy of the main branch?
So depending on where you created that branch, it will be a copy of that. So you can do complicated things where you create branches off of branches, and then they will be copies of that branch. Yeah.
Usually push every branch, or just work locally and then delete it before it's forced to GitHub?
Yeah, I do push all my work to GitHub. So we'll get to that in a second, into like pushing this to GitHub. So that'll be the next step here, is like putting it up there and letting you all play with it.
Talking about like problems with merging, because sometimes
Yes.
lots of them.
Absolutely. That is definitely a goal here for the next half an hour or so, is to get to merge conflicts and resolve those. We will work on that. Yeah. What are the questions about what we've seen so far? So we've seen so far like the creation of a repo, addition of code, and branching, merging. So that's all nice. This is stuff you can do on your own computer by yourself and not even ever go to GitHub. But we have to see that before we can go to the next step, which is to go to GitHub and work there. So the next thing that I will do is go to GitHub now. And let's say I'm ready to share this with the world. Let's create a new repository. And so when you create a new repository on GitHub, who here has ever created a new repository? Just out of curiosity. Okay, so you've seen this before, but let me just reiterate. One of the things that will happen is that you will choose the owner of the repository, and the owner can be an individual, like me here, Rokem, that's my username, or it can be some organization that I belong to, and I belong to too many of them. But one of them is this organization, NeuroHackademy 2025, that you all belong to as well. So this will be interesting. We'll work off of that. And I'll call it geometry. Checks that, and that's available. And I'll make that public. And it gives you some options here for things you would initialize the repository with. But I'll do something that I think is pretty typical in this kind of situation, where you create a repository on your computer, and now you're ready to put it online, which is to create it empty. So if I don't add anything more here and make this public and don't ask to add anything, the repository that will be created is a repository that looks like this. So now that is the location of the repository. github.com/NeuroHackademy 2025 is the name of the organization that owns this repository, because that's how I created this repository, as owned by the organization. And geometry. And so this is the place where the code will be shared. It's public, so everyone can see this. And if you haven't initialized it with anything, it initializes with this helpful guidance for what to do next. So you can create a new repository or you can push an existing repository from the command line. I will follow the instructions given for that. The first command that is given here is git remote add origin with some URL. And GitHub repositories generally have two kinds of URLs. I'll tell you that now because otherwise it gets a little confusing. You can have an HTTPS URL that looks like that. It starts with HTTPS. And we will not use those. We will use the SSH. And that's the reason we created those SSH keys, is so that we can use these SSH repository addresses. And that's why it looks as git at GitHub instead of HTTPS:// and so on. So this SSH address is a way for us to talk to, is a protocol that Git can use in order to talk to GitHub, to push changes to GitHub and to pull changes from GitHub.
What would happen if we use the HTTPS?
Use the HTTPS, it would ask us when we pull it, would pull it happily because it's publicly available and anyone can pull it. But if we try to push, only certain people have the permission to push into this repository. It would ask us to authenticate with a password. Yeah, and then we would be stuck because you need to create some temporary password. It's like this complicated song and dance that you have to do in order to use HTTPS, and that's why we use SSH. I'll do one more thing, which is to change this a little bit, and that's so that we can follow a certain convention. So they say git remote add origin, but I'm actually going to call this remote upstream. This will become clear a little bit later. But for now, let's talk about this complicated command. Git can get a little baroque with very long commands. Git remote is the subcommand of Git that has to do with remotes. Remotes are copies of your repository in other places. Add is the subcommand that adds a new remote. The next input is the name of that remote, and you could choose that name to be whatever you want, whatever string you want. So I chose upstream, and then is the address. So when I type git remote add upstream in the address, nothing really happens except that if I type git remote -v, I have this new remote. So it's recording in the repository. It's recording that this repository has a remote, and that remote is in this location. And then the next step that they recommended was git branch -m main, which I don't need to do, and that's because this modifies the name of the current branch to main, but it is already main because that's how we configured Git locally. You might remember in the configuration that I gave you, there was this thing about default branch being called main. So we don't need to do that, but we will do git push. And I will modify this a little bit too. Git push, again, one of these things that takes a lot of inputs. Git push is the command that takes the local repository and puts it somewhere else on a remote. And the way that it works is it takes as its input the name of the remote and the name of the branch that you're pushing. Typically, you will push a branch to a remote. Recall that I called this upstream, not origin. And they also recommend this -u flag. -u means set this is the place that when you type git push, it will always push to. And I don't want to do that, and that's because I like to be really explicit and always say, where am I pushing? What am I pushing there? So I don't use the -u flag. And I have to type a little bit more, but that actually slows me down. I think that's probably a good thing. So git push upstream main will now do the thing, which is to say it took and it created a new branch. It's telling us all kinds of things. Some of them more obscure than others, but it says to github.com, NeuroHackademy 2025, geometry, git, create a new branch. It's called main. And now if we go here and refresh this page, then now you'll see all the code is up here. Okay. So that was kind of a sequence of things that I do in order to get code that's locally on my machine into the remote on GitHub. And now those two are linked to each other. I'll demonstrate this. Let's do some other changes here. let's go and do one more cycle, git branch, git branch, add test circ, git checkout, add test circ. Hopefully the branch name explains what I intend to do next, which is in test circle, I'm going to test circumference as well. Let's do the same relatively easy case. Circ equals, I need to import, calculate circumference. Circ equals calculate circ. I think I called it that, but we'll see. Circ equals 2 pi, I believe. Hmm?
No, it is an equal listen.
Oh, you're right. 2 equals. Very good. Thank you. Good to be coding in front of people. All right, good. Let's see if it works. Yes. Okay, so now you'll notice that it had 1 test before, now it has 2 tests. Good thing, git status, git add tests, test circle, git push upstream, add test circ. So this is the question you were asking, do I push all my branches? Here I'm going to push all my branches. So I'm pushing, and it'll tell me, oh, there's a new branch here. And this is neat as well. If you push all your branches, you have the benefit that you can do the following. You can see the other branch. So this is on GitHub now. You have, did I? Oh, I didn't commit. No, I did not. Git status. Yes, I did not commit. I have the new branch. I pushed the branch because I created a branch, but it's identical to main so far. I noticed that because I looked up here and I saw fixes tests, which was the commit message from the previous one. And I was like, wait, no, I had added a test that needs to be a different commit message. So going back here, I have the changes to be committed in the staging area, but I forgot to do the commit, which is to say adds test for circ. And then now git push upstream, add test circ. And now if I go up here, I can update and okay, there's this additional thing here. We'll get to that in just a second here. But for now, just notice that there's this, it tells me all kinds of things. It tells me this is 1 commit ahead of the main, it has the commit. I think we can even see what the commit is. So this shows me, I can go to GitHub and see the diff that is between this and main. It's starting to facilitate us towards kind of reviewing code and looking at code changes and things of that sort, so that we do this collaboratively. But let me pause here and see. So now I have on GitHub and on my repo, I have these 2 branches. I could go and do the kind of thing. I'll just show you again let's say I'm very happy with this, added the test, I'm happy to integrate it back. The thing that I would then do is switch back to main, git merge, add test circ, and git push upstream main. And now sort of close the cycle. Now I go to main and refresh. I now have this test here as well. For kind of cleanliness, git branch -d add test circ deletes the branch locally. By the way, if you have not merged the branch, GitHub won't, or Git won't let you do this very easily. So don't worry about accidentally deleting branches. If you use the lowercase d here, it'll say, hey, you haven't merged that. What's going on? So don't worry about that. If you do a capital D, it'll delete it and then you'll be sorry, but don't do that. And then, right, so one more thing, git push upstream add test circ. Then deletes the branch on GitHub as well. So this is a kind of a weird syntax for saying that branch, push it, but in negative. It's like a negative sign on that branch, which essentially removes it here. So now we no longer have a branch in our list of branches. And that's a nice kind of, I don't do that most of the time. Most of the time I keep all my branches and I forget about them. And now I have, in some of my projects, I have like hundreds of branches. And in my GitHub repos, there's dozens of these branches that are obsolete. But it's not a bad idea to not have that because it's a little messier that way. So I just showed you how we did that. And you can decide to be better. Yes, questions?
What's upstream?
Yes, upstream is the name of the remote. I named it upstream rather than origin, which is a name that we usually go. So it's very common that people will take the advice of GitHub and they will name their remote. When I declared the remote, git remote add upstream here, usually the advice that GitHub will give you is to call this origin. This is the so a lot of you who use GitHub will be used to git push origin main, right? That's the kind of standard thing. But you can name a remote whatever you want, and I decided to name this one upstream, and I'll add origin later on. I'll show you what origin is in this context. Yeah, I don't have time for that.
Just like GitHub, like the cloud.
Yes.
Version of.
Yeah. The remote is another computer, in this case, GitHub. Yeah. Okay. Yes.
Is there a reason why you merge your branch locally and then you push the main? And because when you want the first push the branch and it proposes you to make the pull request.
Yeah, that's right. Yeah, so that's the next thing we'll get to.
Okay. Because I'm using this and I would like to know what is the benefit or the.
Yeah. So we'll see the pull request. So now the next thing that we're going to do is move to you using this and starting to do things. So the next thing that we can do, all of us, is hit this fork button. When you hit this fork button, what this does, and I'll show you on mine, and you will do it on yours as well, is it says you want to create a new fork. Who would you like to be the fork owner? And I'm going to be the owner of my fork. And each one of you for your own username will create a fork of this. And so now what this is doing, it's creating a copy of this repository, but instead of the repository being under NeuroHackademy 2025, it's under my username, Rokem. Because we have another copy of this repository, and it has a special relationship with the original one. Right there in small type, it says forked from this other place. And that's important because once you create this relationship by hitting the fork button over here, that relationship allows you to do certain collaborative patterns. This kind of where I'm trying to lead you here is this particular collaborative pattern where your copy of a repository under your username is a fork of the repository on this NeuroHackademy in the NeuroHackademy organization. And now there are, from my perspective, there are two places where this repository exists. And that means that I need to add another remote that I will call origin. And that origin will be this one. Okay, let me not do that for a second. Git remote -v, just to emphasize. I currently have one, it's called upstream, and it's pointing to NeuroHackademy 2025. Now I will add git remote add origin, and that will point to Rokem. So that now if I type git remote -v, it has two remotes, one called origin on my user, and one called upstream on NeuroHackademy 2025. And the exercise for you now is to create a repository with this structure on your computer. And you can do that by the first step. I'll just point out the first step that you can do. It's not a step that, so I'll show you this in a different location on my machine. Here's some temporary directory that the first step that you will want to do is git clone. I didn't do git clone, but git clone is the way to get this repository. Git clone, and let me type that into the Slack as well, because somewhere in your Jupyter Hub home directory, you'll want to do git clone with no, not that address. Sorry, all wrong. Sorry about that. If you did that, don't do it, or remove that directory with this one. You want to git clone this one. Git clone that one. Oh, yeah, okay. Remove -rf geometry, which I already put there. Sorry, those of you who are fast got punished for it by having to remove that directory. But after you remove that directory and git clone from the right place, let me put that in Slack. That is correct. Now, if I go into geometry, it already has a remote configured. That's not what I wanted. Sorry, I apologize. Let's remove this. What I want you to do is actually git clone your own repository. So each one of you will do, like for me, that's a Rokem. For you, edit. After you forked it, this will be username, like that. So, and that's because I want to have a situation for where for each one of you, there is a remote called origin, which is your username fork, and another remote called upstream, which is the NeuroHackademy one. So we'll remove -rf geometry. For me, git clone with my username. Like that with my username. Git clone. Just once the git clone here. If I cd into geometry, now git remote -v is my username. And I can also add git remote add upstream with NeuroHackademy 2025, like that. Right, so this is kind of the situation that we want you to have. One that's your own fork here, and one which is the NeuroHackademy fork right there, in your clone of that.
When I did that, git remote add upstream. No, I was.
So after you, I'll type the sequence of commands into cd geometry. And then git remote. But these are the three commands. The first one makes a clone of the repository. It pulls it down from your username. You made a fork, and you pulled your fork down to your local copy. You changed your directory into geometry, and in there you added another one called upstream that points to NeuroHackademy. So the situation we should have is that for each one of us, upstream is the same place. It's the NeuroHackademy copy. And origin is a different one for each one of us, is our fork. The kind of workflow that this facilitates is a workflow where we can each push to our own origin, our own fork, and we can ask others to merge into the upstream. So the next few steps, what we will do here is we can each make changes to the code on our copy of the code on the hub, push those changes to GitHub, to our fork, and then request to merge into the upstream. So we all request to merge to the same place. And so we can all merge into the same place. That way we can all collaborate on the same set of code that's in one place. And we've all forked from the same place. So when we request to merge, it all goes to the same place, which is this centralized location, which is the organization copy of the repository. Let me demonstrate, and then you'll do that too. So now let's say that I have some code. Let me make something. Git branch readme. Oh, git branch update readme, and then git checkout update readme, in which I go and I update the readme. Created during NeuroHackademy 2025. Okay. So I made a simple one-line change to the README. Git status. I'm on the branch update README. There's a change. It's not staged. Git add README. Git status. Now it is staged. Git commit -m. Explain where, when this was created. Git push, and I always push to origin update README. So the same that I don't make changes to main, I'm not going to make any changes to main. I'm only ever going to merge into main. I don't make changes to the upstream fork. Changes to the upstream fork only ever come from other forks. So now when I go up here to this, we can start using this dialog up here. So the logic here is the following. I am pushing to make some change on a branch. I push that branch to my fork. And now I can go and I can request by hitting this button to create what's called a pull request. A pull request is a request to take that branch from my fork and merge it into the main branch on the upstream fork, right? Everything goes upstream. That's why we call it upstream. Everything goes upstream and then eventually flows down. So that's why it's called upstream. When I hit that pull request dialog, it creates this kind of message here. I can explain a little bit more here in this dialog what I'm doing. And then when I hit create pull request here, an email will go out to everyone who has a fork of this repository, and potentially also to admins of this organization. To many, many different people will get an email in this case that says, hey, Ariel made some changes. He would like to merge them. And so now, let's see if some of you who have forks got an email. You can go and check your email to see if you got an email notification of this pull request. Did anyone get it? No. Oh, somebody went and approved these changes. That's nice. But before you approve it, maybe I'll show you some additional things you can do here. So the nice thing about this pull request and the reason, kind of like the collaborative power of this workflow that we've been kind of working our way slowly towards, is that these pull requests can be created on repositories in which you don't have any permissions to make merges. Right? I don't know if when you go over here, do you see merge pull requests? I'm not sure actually if you have the permissions to merge or not. No, it's interesting. And that's possibly because the permission, you're in one permission group and I'm in a different permission group, but you can still go and you can comment on it. So this dialog, you can see the changes that I'm proposing by looking at this files change tab. You can write comments in here like, I like it. Comment. You can write your own. You can go in here and you can do a line-by-line read of the pull request and make comments line by line, like, this is great. But how about, and then they even have a neat little dialogue here, this kind of arrow to add a suggestion. And maybe I'm suggesting to add a period at the end of this. And then you can start a review, which stacks together all your comments, or add a single comment. And that adds the comment, right? So this appears here. if you do these kinds of commenting, I get an email saying, hey, this person came in and commented on your pull request. We can even go in here and commit the suggested change into the pull request. I can go and I can make more changes. Let's say I will pull that git pull. Update readme. So I'm pulling in that little change so that now I have that period at the end of the sentence here, and maybe with help from participants in the GitHub session. Oops, I closed that. That was not what I was supposed to do. Nice thing about this pull request as well is as I make changes, as you make comments on my changes and I make more changes, git push origin, update readme. Those changes will go into the pull request. So the pull request keeps getting updated as I make pushes into the same branch. It tracks the changes that are made on that branch. And then finally, if everyone's happy, we hit merge pull request. And when that merge request is confirmed, that then goes into the main branch as a merge commit, merge pull request number 1 from Rokem. So again, the kind of logic is, and I need to close the loop by git check out main, git pull upstream main, and now that change came back to me from, so it goes in a circle. I make some changes, I push them to origin, I make a pull request that goes to the upstream fork, and then I pull it back down.
So origin. You pull it back down to origin.
From upstream. I always pull from upstream. Everything comes from upstream. I push it to my origin. I make a pull request from origin to upstream. Once it gets merged there, I pull back the changes from upstream. And when I pull from upstream, I can pull changes that somebody else made on their fork as well. So let's maybe do a little exercise here, which is to kind of work through all of this. Make a branch, make some change somewhere, commit that, push that to your origin, and make a pull request back onto the upstream fork. Yes.
So if I report the larger project and make my local changes and push it to my own or like my own remote branch, would the larger organization that it's forked from see when I'm pushing?
No, unless you make a pull request. If you make a pull request, they would, yeah, that pull request tracks all the changes that you're doing. If you make your own branch and just push it to your own fork, nobody knows about that.
Yeah.
Unless you make the pull request. But the idea here is that many people can collaborate. And this pattern that I showed you here is the pattern that is used by, oh no, I did that. We'll fix it. Yeah. This is the pattern that is used by projects on which some projects on GitHub are collaborations among thousands of people. And this workflow enables that. And that's because you can update, you can always pull from upstream recent changes and update. If you're working on a branch, you can always update your branch with changes that other people have done on their work. And so, for example, the goal of this is to be able to, for example, resolve merge conflicts on your own branch rather than have to resolve them up in GitHub. So it actually addresses, there was a question about merge conflicts, and You might still have time to create a merge conflict or two here. That this workflow avoids most merge conflicts. So that's why I teach it. It's a little more complicated than most workflows that you've probably seen before. I don't know. Has anyone worked using this kind of workflow before? Just out of curiosity. Yeah, okay, a couple of you. It's a little bit more complicated than most workflows people use, but it avoids, for example, a lot of merge conflicts arise because people are pushing and pulling into the same branch. Here, every contributor pushes to one branch that in principle nobody else pushes to. So there's never, and everyone always only pulls from the upstream. So the upstream, you never, everyone pulls from the upstream main and you never work on main. So you'll never have a conflict with upstream main. All your pulls from upstream main should in principle be only fast forward commits that cleanly resolve because they were resolved in the pull request. So you can try to create merge conflicts, but the best way to deal with merge conflicts is to avoid them to begin with. And this helps you avoid the kinds of merge conflicts that otherwise happen when you're pushing and pulling into the same place, when different people push into the same branch. Okay, are you creating pull requests? Let's see. No.
What were the steps again?
But
What were the steps again? If we make a change? What was the task?
the task is to create a pull request with a change. Yeah, so roughly speaking, we're here, git status, you should be something like this. Git pull, first thing you want to do is git pull upstream main to update your local branch. If it says already up to date, you're good. The next thing is git branch some new branch. Make changes. Git commit -m or git add changes, right? Git commit changes, and then git push origin new branch. And then once the new branch is there, make the pull request against upstream main by going, oh, there you go. Thanks, Vanessa. Thank you. Yeah, I'll merge that. But let's wait for another few pull requests to come in. Things might get complicated. So the way that a merge conflict might still arise if two different people make a pull request on the same line in the same file, right? We'll see if that happens. And then we'll need to deal with those. In fact, I will create a merge conflict for myself now by conflicting with Vanessa's code. Let me see. So I think let's go to this one because I think it would be relatively easy to create. Let me try to create a merge conflict here. So that one was before the oh, this one is at the very end. Okay, good. It might still be able to deal with this, but we'll try. So what I've tried to do is I've tried to create a branch and a pull request. I will try to create a pull request that conflicts directly with. I didn't have. Oh, it. Oh, there isn't anything to do here. Why is that? Oh, I did not, I made these changes on my main branch.
Yeah.
Hmm. Let me make those changes again. Okay, so now I'm trying to create a pull request that conflicts directly with Vanessa's pull request. And I'll go and merge hers first, and then we'll see how we can resolve this nonetheless. So I'll merge this haiku pull request first. And then let's see what happened to my pull request. Okay, so this is the kind of thing that will happen that it will say this branch has conflicts. So what happened here, just to kind of explain high level, the way that conflicts can still arise in this situation is if two people make different changes to the same exact lines of code. So in this case, I intentionally went and saw it, and I said done, and I intentionally made a different change there. And it'll say I can't deal with this. This branch has conflicts that must be resolved. Now, there is a way to resolve the conflicts in here. It actually gives me an editor where I can edit these lines of code to be perfectly happy. So I can go and I can say, it inserts these, who here has seen conflict markers in GitHub? If you've created merge conflicts, you've seen these. These are these markers here surrounding this text that tell us that new branch, which is my branch, contains the content between this line of equals and this herringbone marker, and then main contains this. And I can, in fact, in this dialog in GitHub, I can go and I can edit this whichever way I want. Like I can say, oh, actually, let's reject my changes, and then mark is resolved, and then the branch that my pull request, which had the conflict, would be resolved. In this case, it would be resolved as nothing happened. I can also go and I can resolve this conflict on my local copy in the hub. So I'll show you how to do that. So this is one way to resolve this conflict, but let's close it without marking as resolved. So that didn't happen. Instead, I can go and I can go status just to make sure that I know where I am. So I'm a new branch, git checkout main, git pull upstream main, and because interesting. Let's see, did it? Oh, it didn't pull the. Yeah, it doesn't like the. It doesn't like to do that. Let's see. Oh, I know why, because I added this other change to the README. So it's really not liking this because I actually created the conflict also on my main branch. I got into a bit of a situation here, but we can resolve that. Normally we can, if I hadn't made some mistakes here, we could have been able to resolve this here as well. Basically by pulling from upstream, merging into the branch instead of merging from the branch to main, we would have merged in the opposite direction, resolved the conflict on the branch, and then happily kept on going. In this case, we can go ahead and use GitHub to resolve the conflict like this. Let's say we don't want my changes, and that marks that as resolved. It commits that, and I should be able to keep going, hopefully. Yeah, now the change is, I think, nothing. Yeah, it's just a new line. Yeah, questions?
Just to clarify, well, so you create a clone, or you fork the reason you have your own origin on your computer.
Yeah.
You make a change to your origins and then you push the change to your origin, or do a pull request from your origin to the branch upstream.
Yeah, and usually the pull request is from your branch on your fork to the main branch on upstream. We're trying to get everything to go to the main branch on the upstream fork.
So you create a fork, or you create a branch in your own fork version of it, or you just.
You create the fork on your machine.
Yeah.
When you begin developing, you should do git checkout main, and then git pull upstream main, which in my case is gonna cause some trouble because I made the mistake. What I did was a mistake that you shouldn't do and is a little tricky to get out of, which is that I made a commit directly on my main branch. And then not only that, I made a commit on my branch that has a conflict with what's in main and upstream. So if you get into that situation, you need to do a little bit of surgery on your repository that I will not do right now. But in principle, what you need to do is git pull upstream main first to make sure that your main your main branch is up to date with what's on upstream. Then you make a fork on your copy of the repository, on your machine. You make a branch, not a fork. Sorry, all this terminology is quite confusing. You make a branch on your machine and you push that branch to GitHub. And then you ask to pull from that branch into the main branch on the upstream. And then you pull it back. So it goes in a circle. You make a branch on your machine, you push that branch to origin, you request to pull it into upstream, and then you pull from upstream, and so on, and so forth.
Why is it bad to make the change right in your origin?
You're going to make changes in your origin, just not in the main branch. You want to avoid working on the main branch. The main branch is kind of like the pristine reference branch that everyone uses. Remember that case of like, you have this lab meeting in a couple of weeks and you want to have a branch that's clean. Now, if you're collaborating with many other people, that branch needs to be a branch that nobody really touches except by merging a pull request in there. And the nice thing about using the pull request in order to merge into the main branch is that somebody else, if the project, one of kind of the rules you can institute is that you never merge your own pull request. Somebody else has to review your code before it goes into the main branch. So that's kind of a way to make sure that it's vetted by other people. I mean, in the extreme case, you're asking to merge your pull request into a project that somebody else owns, and that person doesn't even know, they don't even know you, right? And we'll see, we'll see a little bit later this week, we'll see GitHub Actions. Serge is going to talk about that on Friday. GitHub Actions is a way to have GitHub run all your tests on every pull request. So you automate the running of the tests such that when I submit a pull request against your repository, the tests are there, they're running, and I don't need to pull down a copy of your code and run your tests because they run on GitHub for me. And then GitHub, I'll show you an example of that. One example of that is DiPy, where we have a bunch of automated tests. So here's a pull request. Somebody is proposing to make some change, fixing some bug, for example. This is Serge, who you'll hear from tomorrow. And every time he makes every time he pushes a commit into this branch, a series of machines on GitHub will go and run all the tests. They'll install all the dependencies, they'll install the software, and then they'll run the full test suite. In this case, a quite extensive test suite with lots of tests, these little test scripts that I showed you. They just all run up here. And if one of them fails, did one of them fail here? No, none of them are failing right now. They're all passing right now. But some previous iteration of this, maybe some test failed. Instead of me checking his code, I can just tell him, look, the tests are failing, go fix that first before I merge your pull request. So the nice thing about that is that it puts the onus on the code contributor rather than the code maintainer. One of the issues with managing these kinds of repositories is lots of people show up and say, hey, I want to change this, I want to change that. And if you're maintaining that and you're the one who has to direct the traffic, you want tools that help you make that smoother. And these GitHub Actions help make that smoother. So you'll see more examples of GitHub Actions from source. There are all kinds of ways to use that. And I think he'll show in detail how to configure that. But for now, the context is these pull requests make it possible to collaborate with a lot of people, often people you don't even know. You can make a fork. You don't have to be in the organization or related in any way to a project in order to make a fork of that repo. This is why this is kind of the most general collaboration pattern. It's a little tricky to teach on kind of in a short span of time, but we'll get to practice it a lot. That's the hope is we'll get to practice this a lot next week and figure out other and learn more about these collaboration patterns. It's the most general one. You can do this with repos that you collaborate with people that you know on, but you can also do this on repos that are from some other random people on the internet. Maybe you go in and you suggest your changes to some software that many other people work on. It's the one that scales the best in terms of working with many people. So that's why I thought it would be worth kind of teaching. Okay. What other questions are there at this point? I realize many of you might have like dangling bits and pieces here, but we will come back to this. You'll definitely get to work with more with Git and GitHub starting tomorrow morning. So so there will be more opportunity to practice this and get more closure on this. Let me see if there are questions on Slack. Okay, if no more questions, no more burning questions at this moment, then let's close here and then we will resume in 30 minutes with something completely different on machine learning and deep learning, and we'll come back to Git and GitHub as soon as tomorrow morning.